I have a problem. Up on my bench is a perfectly functional 150-pound mini bike. See it sitting up there all precarious? I'd take it down to show you its top speed, but it wasn't easy getting it up there. With the stock 196cc motor, it peaks around 50 kilometers an hour, or 30 miles per hour. I want to introduce it to a 30 kilowatt electric motor from Electro & Co. This frame was designed for 5 horsepower, and I'm going to introduce it to 40. Forcing the two of them to occupy the same space will be a serious engineering challenge. My goal isn't just to make it fit, it's to combine the suspension and overbuild 1.25" frame with the unrelenting violence of a high voltage system to build the fastest mini bike to ever touch the staging lanes. If you think this is a problem that needs solving, grab a wrench. Let's see if we can find the breaking point. Everyone knows the saying, it's not the volts that kill you, it's the amps. Well, you actually need both to do lethal damage. This battery I'm holding does both. It's a 20S 40 amp hour lithium ion battery that packs a walloping 400 amps at a max of 84 volts. Any stray metal that bridges the contacts will instantly spot weld and will short the battery. This multimeter, I used the wrong setting to test the battery and it literally evaporated the positive lead into a cloud of white smoke. That arc flash was no joke. My hands were inches away from the power of an arc welder. Violent storage devices. That's what I like to call batteries. The power required to feed this 30 kilowatt electric system is truly immense and is the first engineering obstacle we have to tackle. To do so, we need a solid roadmap. So here's my wiring diagram. It's really not that complicated, and we're going to be going through each part of the system to understand the engineering behind the power. We've already covered the battery, the heart of the build. Next is the main high voltage fuse. I'm using a T-type fuse. They are the gold standard for lithium systems due to their extremely fast actuation time. This will be the only thing protecting my expensive circuit from the brutality of an electrical short with this battery. Next is the 2-pole breaker. It acts as the floodgate for the entire system. I've included one to create a perfect zero draw when the bike is in storage. It acts as a switch for both the positive and negative leads, isolating the hardwired battery from the rest of the bike. Our next stop on the diagram is the 72 to 12 volt converter. It supplies 10 amps of clean current for the entirety of the 12 volt circuit. This includes the headlight, the fan for active cooling on the battery, and for supplying power to the coil side of the contactor. This brings us to the star of the show, the main high voltage 400 amp contactor. This beefy thing is the main switch that prevents the high voltage system from reaching the controller and motor. It has a coil side and a switch side. When the 12 volt coil is activated, an electromagnet attracts the main switch closed, clamping shut and completing the high power circuit. The beauty behind this component is how it allows me to control the main power of the bike through a simple thumb switch on the handlebar. No giant industrial toggle switch necessary. Coming up, the main brain of the bike, the motor controller. This heavy-duty component takes the 400 amps of current supplied through the contactor and chops it up into 3-phase signal at about 700 amps of phase current. 400 amps one end, 700 amps the other. It takes the throttle input and mode selector switch and converts these tiny signals into the earth-shattering torque we can expect from this motor system. This Votol EM260 controller supports regenerative braking, where you run the motor in a generator mode that recharges your battery as you decelerate, and flux weakening, lowering current output when the motor is at max RPM to squeeze out more performance. Finally, we have the muscle of the system, the QS138 90H V3. This behemoth of a mid-drive motor supports 4 kilowatts continuous and up to an astounding 30 kilowatts peak power. This is a motor designed for full-size motorcycles and adult go-karts capable of over 100 kilometers an hour. I want to highlight the internal gearbox that limits the RPM of the motor down to 2.46 to 1 ratio that will keep the motor running at its peak efficiency and torque while keeping the size of the rear sprocket small. This motor is capable of 250 foot-pounds of force. Truly hand of God territory here. This bike will accelerate like the Millennium Falcon. Now that you see why I chose each of the major components, here's a quick rundown of how each of them will work together to safely supply the bike with 8 times its stock power. First, I will flip the breaker to the on position. Then I will wait 5 to 10 seconds while the resistor across the contactor poles pre-charges the internal capacitors. Without this resistor, the massive inrush of power would cause the contactor gate to slam shut and instantly weld itself together. This single component prevents catastrophic failure every time I turn the key. Second, I will switch on the key switch. This switch controls the input of the 72 volt to 12 volt converter. When I turn it to the on position, the bike will enter ignition mode. This is where all the accessories will power on. Third, I will switch on the handlebar toggle switch. This switch controls the power to the coil side of the contactor. This will act as the main power switch for the bike. In addition to these switches, I'm including 2 indicator LEDs. One green one will indicate when the pre-charge circuit is activated and will turn off when the system is fully pre-charged. And then next I will have one red LED in parallel with the main contactor coil. When the bike is hot, the red LED will be on as a warning. In the next video, we're going to go over the mechanical and structural changes this bike requires to take both the increased power and the increased rider weight for my 270-pound self. By the end of this series, I'm taking this bike down to the drag strip to see if a custom-built pit vehicle can actually gap a purpose-built race car. If you want to see what it takes to strap 30 kilowatts to a mini bike, grab a wrench. Let's find the breaking point.